Hi everyone, this is Mrs. GA, and today we're going to be solving linear quadratic systems. I'd have a quick warm-up for you guys, so if you could pause the video and give this a try, we'll check your answers in just a few seconds. Alright, go ahead and check here. So for the standard form of a circle, remember it's x minus h. H is the x of your center plus squared plus y minus k. K is the y value of your center squared equals your radius squared. So for this, just be careful that you're squaring both the 3 and the root 7. All right, so we're going to start by solving some systems that have a quadratic and a linear portion algebraically. So there are different ways we can go about these types of problems. So for this one, I'm going to show you how to solve it using substitution. So one reason why I'm using substitution here is because I see that I have isolated a variable already. It says y equals all of this. So I can really just take this right here and substitute it into my other equation for y. And let's see what we get. So that would give us 3x minus 2 times 1/4 times x minus 3 squared equals 13. And here we just have a quadratic equation that we can start simplifying. So we are going to need to multiply this out so we can set our equation equal to 0. And just to clear my fractions before I go any further, I am going to just multiply both sides by 2, giving us 6x minus x minus 3 squared equals 26. Here, just make sure you're multiplying out your binomial properly. Remember, x minus 3 squared means x minus 3 times x minus 3. So it's x squared minus 6x plus 9 equals 26. And we do need to distribute that negative. And then I'm going to set my equation equal to 0. In order to make my a value positive, I think it's best to actually add or subtract all of these to move it to the right side of the equation. So we get x squared minus 12x plus 35. And then here I see that we can solve this by factoring. So that's probably the method that I would always go for if it is possible. So we get two solutions here, x equals 7 and x equals 5. Remember, the solution of a system is really where these two lines are intersecting, so they do need to be coordinates. So we do need to find the y values that go with each of these x values, and you do need to find them separately. So first, we need to figure out what y value goes with x equals 7. So I'm going to substitute that into either equation. It's going to be easier for us to substitute it into our linear equation. So here we got y equals 4. So one of our solutions is 7, 4. It should always be an ordered pair. And then we should have one more solution for x equals 5. So again, we're going to substitute it in. And here we get y equals 1, so our second solution is 5, 1. So we have two solutions here because these two lines are crossing twice. This is very common for this type of system because, again, we have a parabola, so we have maybe something that looks like this, and then we have a straight line. So it's very common for those two types of lines to cross twice. Okay, let's do one more together. So here, again, there's different ways we can go about this, but I'll use substitution again. So for this first one, I can solve for y, and then I can substitute it into my other equation, or vice versa. So here we get y equals 3x minus 7, and I'm going to take this, and I'm going to substitute it right here so I can solve for x. So we get 3x minus 7 plus 1 equals 2 times x plus 5 squared. So here, let's combine like terms and let's start multiplying this out. So we have 3x minus 6 equals 2 times x squared plus 10x plus 25. This gives us 3x minus 6 equals 2x squared plus 20x plus 50. And then let's set our equation equal to 0 so we can finish solving. So here we get 2x squared plus 17x plus 56. So you can try solving this in whatever way you'd like. I'll use the quadratic formula. So let's do x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So when you keep simplifying this, what you end up with is the square root of negative 159 all over 4. So I know when we were solving quadratics previously, we know that this has no real solutions, but it does have two imaginary solutions. But for a system of equations, we are really looking for those points of intersection. And so if there are no real solutions, then we can't actually solve the system. So for systems, we never look for imaginary solutions, which means whenever you get a scenario where you do have imaginary solutions for x or y, we would just say no solution. So again, we are looking for like physical points of intersection, and you can't have imaginary points of intersection. All right, so I have one for you guys to try on your own. So if you could please pause the video and give it a try, that would be great. All right, go ahead and check your work here. For this one, I think the easiest way to go is definitely solving for x with the linear equation and substituting it into your quadratic so we can solve for y. And when you're doing that, feel free to simplify or multiply both sides of your equation along the way to clear your fractions. So here you can see I multiplied both sides by negative 6 to clear my fractions and my negative. And what you end up with is a much, much simpler quadratic equation to solve. So we get two y values, which you can substitute in to find your two x values, and these two coordinates should be your solutions. So now we're going to be solving systems with more conic sections. So that could include parabolas or circles, which we've been learning about, or ellipses or hyperbolas. And so for these, there's actually a lot more different scenarios for the types or for the number of solutions you can get. So it's still very possible to get two or no solution. So you could have, let's say, two parabolas, right, that just never cross. It's also very possible to have one solution. So even, let's say, a circle. You could have a circle and a parabola like this that only intersect at one point. Also very common to get two solutions. So let's say maybe I have two parabolas, one that looks like this and one that looks like this. So this would have two solutions, very common. You could also end up with three solutions. So let's maybe imagine a circle like this and maybe a parabola like this whose vertex falls on your circle. So you could have 1, 2, 3 points of intersection, or you could even have 4. So let's consider again a circle like this and maybe a parabola that looks like this. So it is very possible to have 4 points of intersection. All right, so let's try solving some of these together. So here we have two equations of circles. So we're going to solve the system, and again, we're trying to find the points of intersection of these two circles. So for this, we can actually use the elimination method where we add vertically. We have all of our terms are already lined up. And so let's take our bottom equation and subtract it from our top equation, and let's see what we get. So here we have x squared minus x squared is 0x squared, so our x squared terms cancel out, and so do our y squared terms. And then we have 10x minus 9x, which is just x. You can see here our y squared terms, or our y terms also cancel out. And then here we have 84 minus 80, so we get plus 4, and then we get equals 0. So here we actually just get one x value as our solution. And then we do need to plug it into our equation, to either of our original two equations, to find the y value or maybe y values that go with it. So let's substitute -4 for x into our first equation. So we get -4 squared plus y squared plus 10 times -4 plus 16y plus 84 equals 0. And so here I do have a quadratic equation for y that I'm solving for, so implying we're probably going to get two solutions for y. So let's simplify what we have here. We have y squared plus 16y, and then plus 60 equals 0, and we can actually solve this by factoring. So y plus 6 times y plus 10 equals 0, so we get y equals -6 and -10. So we actually have 2 points of intersection, -4, -6, and -4, -10. So what's happening here is we just have two circles, again something like this, and then something like this, that happen to be intersecting along the same vertical axis, which is why the x values are the same. All right, let's try another one together. So here, again, there's different ways you can go about solving this. We can use the addition method again, but I would probably rewrite this to line up my terms a little bit better. So I'm going to take my top equation and I'm going to line it up underneath my bottom equation so the terms match. So I'm going to say 3y squared plus 32x minus 12y minus 20 equals 0. So again, I was just rewriting this below. And then here I'm just going to add vertically because I can see these terms will eliminate, which is exactly what we would like to happen, and these terms also eliminate. So that gives us 21x squared. Again, this turns to 0 plus 84x, and then this also turns to 0. Minus 105 equals 0. So now we have a quadratic equation, so we need to finish solving for x. So here I'm actually going to divide both sides by 21 to simplify my quadratic before I keep solving. And then here I can solve by factoring again. So we get two values for x. So we get -5 and +1. And we do need to substitute both of those x values into either of our original equations. So I'll substitute it into this equation to help us finish solving for y. So let's start by substituting x equals -5. So we have 3y squared plus 32 times -5 minus 12y minus 20 equals 0. So here you see that we actually have a quadratic equation. So let's simplify it. And then I'm going to divide both sides by 3 just to simplify our quadratic a little bit more. So here we should get y minus 10 times y plus 6 equals 0. So we get two values for y here. We get +10 and -6. So from just this x value, we have two coordinates that would be part of our solution. So far we have the coordinates -5, 10 and -5, -6. And now we can substitute our other x value. So now we have to substitute x equals 1 into that same equation I'll use. So 32 times 1 minus 12y minus 20 equals 0. So we have 3y squared minus 12y plus 12 equals 0. So let's divide both sides by 3. All right, and here this leaves us with y minus 2 squared equals 0. So here we actually just get a single y value as our solution, even though it's a quadratic. So that means that our third coordinate, our third point of intersection, is at 1, 2. So we have 3 solutions for this system. All right, so at this point, I'm going to ask you to pause the video and see if you can give this one a try on your own. All right, go ahead and check your work here. So I rewrote that top equation underneath my second equation to line up the common terms, and then I subtracted. So be careful here when you're doing negative 20 minus negative 39, you do get a positive 19 here. And then this is a simple quadratic equation. You get y equals plus or minus 1. Don't forget that plus or minus. So you do need to substitute both positive and negative 1. So when you substitute y equals 1, you get 2x values. So that gives us these first two coordinates. And when you substitute negative 1, you get 2x values. So that gives us our second two coordinates. So this system actually has 4 solutions. Okay, so now that we have solved our systems algebraically, now we're going to try solving them graphically. So we can solve by graphing manually. We just graph both equations and then we find the points of intersection. The one downside to this, if you're doing it manually, is this really only works if you have really nice solutions that fall over maybe integers. When you start to have fractions, this method is a little bit, it's not as reliable. So you can do it manually. It really only works for nice problems, but we can also do this with our graphing calculator. So here I have some steps for how to graph and find the points of intersection on your graphing calculator. So we can do this for more complex or a little bit not as nice problems. So first we are going to try to solve this system by hand, so without using our graphing calculator. So let's look at our two equations. This first equation, this top equation, I'll highlight it in blue. This is a horizontal parabola. We can see that our vertex is at negative 3, 2. And it is, since our p-value is positive, it is going to open to the right. Now for this one, we don't actually need to graph the focus and directrix because we really are only trying to find where these two lines intersect. Okay, so let's try to get at least 1 or 2 more coordinates on this graph. So I'm gonna plug in x equals negative 2 and then solve for y to get that extra coordinate. So we have y minus 2 squared equals 4 times, and again, if I'm plugging in negative 2, this just becomes 1. Here I can take the plus or minus square root of both sides, and then I can add 2. So when we substitute, again here we just substituted x equals negative 2 to find some more coordinates. We get 2 y values. We get y equals 4, or we get y equals 0. And so let's plot those points. Sorry, so our vertex should be here at negative 3, positive 2. And then we have the points negative 2, 4, and we have the point negative 2, 0. So again, we have the two coordinates, negative 2, 4, and negative 2, 0. So we get something that kind of looks like this. And now let's look at our next equation. So here we have a vertical parabola. And I can see that our our vertex is at negative 3, 2. So we have actually the same vertex. And now to get a couple more points, let's pick an x value to plug in. So let's substitute x equals negative 2 to see what we get. So when I do that, again into our second equation, we get negative 2 plus 3 squared equals 1/2 times y minus 2. So this gives us 1 equals 1/2 times y minus 2. We can multiply both sides by 2, and we get y equals 4. So we get the coordinate -2, 4. And we can, of course, reflect this to the other side of our axis of symmetry. But in doing so, we can already see that we have our 2 points of intersection. So our points of intersection are here let me write my solution to the side, at -3, 2, and we have another one here at -2, 4. So we have 2 nice clear points of intersection. And again, this is really just working because these are nice equations. It just so happened that we have points of intersection that are nice whole numbers and easy to see. Now, since as we talked about, graphing really only works well when you're doing it by hand if it's a really nice problem. Now we're going to try one where we can use our graphing calculator. So again, on that previous slide, I had the steps on how to do this, but one thing you do need to know is to plug this into your graphing calculator. You do need to solve for y. So for this one, you're going to be plugging in y equals 2x minus 3. That's if you solve for y for this first equation. And for the second one, you can do y equals 2 times x plus 1 squared minus 6. So take a moment and plug those two values in, or those two equations into your graphing calculator. And then you should get, I'm just going to do, of course, this is a super rough sketch, but you should have a parabola that looks something like this. And then you should have a line, I'll use blue, a linear equation that looks something like this. So our goal now is to find these 2 points of intersection with your graphing calculator. So remember, if you if you hit second and then that trace button gives you some different options to calculate, and what you will calculate is the intersection. It's going to ask you to trace along a first curve. So you're going to scroll over on your first curve until you're close to your point of intersection, then you hit enter. And then you trace along your second curve until you're close to that same point of intersection. You hit enter again, and then it will ask you, it will say guess, and you hit enter again, and it will give you an estimate, and it will tell you both the x and y values for both. So for this point right here, you should get about -1.366 and then -5.732. And then for this coordinate, we should get about 0.366 and -2.268. So you can see that graphing, if we had to do this by hand, would definitely not be able to give us exact answers. We would really just be able to look at our graph and kind of guess. But if you're using your graphing calculator, you get a much better estimate. So please make sure you know how to use that intersect functionality on your graphing calculator before the test. All right, so that is all for today's lesson. Thank you so much for watching.